Welcome back to the deep dive. Today we're tackling one of those really key questions in app security.
Yeah,
It's the question that comes after you've already logged in. Okay, I'm in, but what can I actually do here?
that's one. Yeah. Our mission today is really to get into authorization.
Right.
It's, the bedrock of security of access control. We're going past just who the user is.
Right.
We're digging into the main ways systems decide what you can do. The big three: RBAC, ABAC, and ACL.
Okay, let's nail down that difference first because people mix them up. Authentication, that's proving who you are, your login. Confirmed.
Mm-hmm. Identity check.
But authorization,
Yeah.
that's about capability, permission. Like think about GitHub maybe. Logging in, that's authentication.
Right.
But authorization decides if you can push code to this branch or review that PR or maybe the big one, can you hit the delete repo button? That check, that's authorization.
Exactly, that capability check. And pretty much every system uses one of, well, three main models for this, or actually more often some kind of mix of them.
Okay, let's start with the one most folks probably know because it feels like the standard. Role-based access control, RBAC.
Yeah, RBAC.
Yeah.
It's super common, mainly because it's pretty straightforward, at least to start. The idea is simple. You assign users to roles, and each role just has a set list of permissions.
Right.
The big win is you're not managing permissions user by user, which would be crazy. You manage permissions for maybe 5 or 10 roles instead of thousands of people.
And we see the usual suspects, right? Like admin gets everything, editor can change stuff, viewer can only look.
Exactly that structure.
Yeah.
Makes it easy to manage initially.
Initially, so there's a catch.
There's definitely a catch. It's
That's
something
what
called
there's-
role explosion. As things get bigger, more complex, those simple roles just don't cut it anymore.
Right, you need more nuance.
You do. And you end up with dozens, maybe hundreds of really specific roles, like editor marketing tier 1 US, editor support tier 2 EMEA, just tiny variations. It gets messy. RBAC's simplicity bites back when you need flexibility.
Okay, that makes sense. That pain point probably leads systems to look at door number 2 then. Attribute-based access control. ABC. Sounds different.
It is. It's a big shift. ABAC doesn't rely on those fixed roles. Instead, access depends on attributes.
Attributes, like what?
Attributes about the user department, maybe security clearance, job title.
Yeah.
Attributes about the resource, like how sensitive is this data, what type of document is it,
Yeah.
and even context, like what time is it, where's the user logging in from.
Whoa. Okay, that sounds incredibly fine-grained. You're moving past editors edit content to something way more specific, like a policy.
Exactly. It's all policy driven. You might write a rule like if user department is HR AD, the resource dot sensitivity is not high and time is before 6 p.m.
Wow.
So you can combine all these pieces, who the user is, what they're trying to access, and the situation to make a really precise call.
That flexibility sounds amazing. But, I'm sensing another but. If you have thousands of rules like that, all interacting, managing that sounds like its own headache.
It absolutely is. Complexity is the trade-off, no question. You can't just scatter that kind of logic through your app code with if statements. It becomes unmanageable fast.
So what do you do?
You need a dedicated policy engine, something sophisticated to handle evaluating all those rules. And critically, these often use special policy languages like Rego, or AWS uses one called Cedar. Trying to code that complex logic directly in Python or Java, forget it. You need that declarative policy approach for ABAC to actually work at scale.
Okay, fascinating. That's a big architectural choice. Right, let's hit the third model, access control lists, ACLs. So if RBAC is roles and ABAC is attributes and context, where do ACLs focus?
ACLs flip it again. They go straight to the resource itself. The permission, the rule, isn't attached to the user or some central policy. It's attached directly to the thing being accessed.
Like a file?
Exactly, like a file or maybe a specific database row or an API endpoint. Each one has its own little list saying who specifically users or groups can do what, read, write, delete to it.
Okay, the example that jumps to mind is file sharing.
Perfect example. Think Google Drive. Anyone who uses it gets ACLs. Every single file, every folder has its own share settings, right? That's an ACL. It defines exactly who can view, who can comment, who can edit that specific document. It gives you incredible granularity.
Unmatched granularity sounds like. So benefit is control. What's the downside compared to, say, RBAC?
Scale and management mostly. Yeah, it's granular, but imagine managing ACLs on millions or billions of individual items.
If you need to revoke Bob's access because he left the company.
Right. You can't go edit 10 million separate lists. It's impossible. So you need clever abstractions. You grant access to groups, not just individuals. Or you rely on permissions flowing down from parent folders. Without good abstractions, checking those lists for every single access request can become a real performance bottleneck.
Okay, so those are the three main flavors, RBAC, ABAC, ACL. But you said earlier that real systems usually blend them.
Almost always, yeah. Especially larger platforms. It's rare to find a pure system using just one. They mix and match to get the best of worlds, maybe the structure of RBAC with the granularity of ACLs, or the flexibility of ABAC for specific, tricky rules.
Let's go back to GitHub then. How are they blending things?
GitHub's a great hybrid example. You've got clear roles like owner, admin, member, collaborator that's pure RBAC. It sets broad permissions for the org or the team.
Right, like billing access or adding team members.
Exactly. But then you go down to a specific repository, you can set branch protection rules. Only these specific people or this team can merge to main. Or you need specific approvals for pull requests on this sensitive repo.
Ah, so that's getting specific to the resource.
Precisely. That's moving beyond the general role into resource level control. It feels like ACLs or maybe ABAC, depending on how dynamic the rule is. RBAC gets you in the door of the org, but ACLs or similar protect the crown jewels repo.
Gotcha. Any other examples, like Firebase?
Oh yeah, Firebase is interesting. It uses this real-time rules engine. Developers write rules, often in a JSON-like structure, that define access. And those rules very explicitly combine things. You might check request.auth.token.role. That's RBAC-ish.
Okay.
And also check resource.data.owner-ID or request.time. That pulls in resource attributes and context, which is very ABA. So it's like an explicit hybrid instruction set tailored for real-time data access.
Okay, this is making sense. The model RBAC, ABAC, ACL, or the blend that defines the logic, the rules. Now, how is that logic actually enforced across the internet, between my browser and the server? That's where things like OAuth2 and tokens come in, right?
Exactly. Now we're talking about the mechanisms of enforcement. How do we make sure those rules are actually followed? And yeah, OAuth2 is fundamental here.
And super important to remember, OAuth2 isn't primarily about logging in. People get that wrong all the time. It's about authorization, specifically delegated authorization.
That's the key phrase, delegated authorization. It's the standard protocol that lets you, the user, grant limited permission for one application to access your data held by another application. Crucially, without you having to give your main password to that first app.
Right, like letting that third-party calendar app post to your Slack. Slack doesn't give the app your Slack password. No way.
Definitely not.
Instead, Slack, using the OAuth2 flow, gives the calendar app a special key, a token. And that token has very specific limited power, maybe just the permission to post .messages in a certain channel.
Precisely. And that token becomes the currency, is what applications pass around to prove they have permission for something.
Okay, let's talk about that currency then. Access tokens, often JWTs, right? JSON Web Token?
Very often JWTs, yeah. They're a common standard. So after you log in, authenticate, the system you logged into gives your browser or app an access token. It's digitally signed, so it can't be easily faked or tampered with.
And what's actually inside that token? What info does it carry?
It carries claims, key pieces of information. Typically, you'll find your user ID, so the system knows who it's for, maybe the roles you have, or specific scopes of permission you are granted, like that post.messages scope. And really importantly, an expiration time. Tokens don't last forever.
Okay, so my app gets this token, then what? It sends it with every request.
Yep. Usually in the authorization header as a bearer token. Then the backend service, the API it's calling, gets this token. It has to do a few critical things.
Walk us through that backend check. Step one.
Step one, verify the token, check the digital signature. Is it legit? Was it actually issued by us? Is it expired? If anything's wrong, request denied immediately.
Okay, signature's good. It's not expired. Step two.
Step two, extract the claims, read the user ID, the roles, the scopes, whatever useful info is packed inside.
Got it. Now the crucial part. Step three.
Step three, check the policy. This is where it connects back to RBAC, ABAC, ACL. The backend takes those claims, like user ID 123, role editor, and runs them against its internal authorization logic. Is user 123 with role editor actually allowed to perform this specific action, like delete document, on this specific resource?
That is such a critical distinction. The token carries the verified claims like a passport with visas, but the backend logic is the border control agent who actually reads the passport and applies the country's rules to decide if you get in here right now.
Perfectly put. The token is the secure messenger.
Right.
Your backend authorization code, your policy engine, that's the decision maker. The token doesn't make the decision itself.
Okay, let's do a quick wrap-up of the main ideas then.
Sounds good. So authorization, what you can do. We covered RBAC, simple roles, scales okay at first, but can lead to role explosion. ABAC dot super flexible, uses attributes and context, needs a policy engine, more complex. ACLs dot granular, tied to the resource, great for things like file sharing, but can be tricky to manage at massive scale.
And then the mechanisms to make it all work. OAuth 2 for secure delegated permission.
Right, letting apps act on your behalf safely.
And tokens, like JWTs, carrying the claim's user ID, roles, scopes, expiration that the backend uses to enforce the rules.
Exactly, that's the whole picture, pretty much.
Okay, that was a solid deep dive into how access is actually controlled. We saw how the models blend, how they balance structure and flexibility. But here's something to chew on as we finish. We hammered home that the token is just the messenger carrying claims. The real decision happens in the backend's authorization logic, the RBAC or ABAC engine that reads those claims. Now, you can have a perfectly valid token, good signature, not expired to correct role claims, but what if the backend code that interprets those claims has a bug? What if the policy logic accidentally grants editor access to delete financial records when it absolutely shouldn't? The token mechanism worked perfectly, but the authorization logic failed catastrophically. So the question is, how vital is it to apply the same intense auditing and security rigor to your authorization logic and policy configurations as you do to your token handling and cryptography? Is one more important, or are they equally critical links in the chain?
That's a really sharp point, and yeah, absolutely critical to consider both. A chain is only as strong as its weakest link. Fantastic food for thought. Thanks for joining us on this deep dive.